All right, GM, everyone. Good morning, good afternoon, good evening. Let's give it 1 or 2 minutes for people to come in and then we will get started. What's up, Wagged? Okay, how's everyone's hackathon experience been so far? Okay. All right, we'll give it 1 more minute and then we're going to get started. Just getting my bearings around again. It's been a while since I've done one of these actually, so it's kind of exciting to be doing it again, I should say. All right, I think we've waited long enough. Oops, something happened to my sound. There we go. All right, let's get started. So welcome everyone. My name is Harry. I lead the DevRel team here at Chainlink Labs, and I'm very, very excited to talk to you guys today about confidential HTTP requests in CRE. But first of all, we need to talk about the hackathon and the new privacy track. So I'm just going to share my screen for you. Oh, give me 1 second. Okay. There we go. So for those who don't know, but hopefully you do, we added a privacy track to our hackathon where we have $16,000 in prizes. And these are going to go to the 2 best projects that really showcase how you can utilize CRE in a privacy preserving manner. So we're really interested in seeing what kind of projects you guys come up with. And we kind of have 2 ways in which you can implement privacy with CRE that we're going to be really pushing. And this workshop here is going to talk about the first one there. So if you haven't seen the privacy track description, please go to the Hackathon website and go to the prizes section and you'll see a description here. Okay. Now that that's done, let's get started. So for those who may not know, Chainlink Confidential Compute went live. It was announced at SmartCon, I should say, in November last year in New York. It was quite a big moment for us, and we put out this blog, which I'll actually put in the... I'm going to put it in the chat for you guys to check out if you haven't seen it already. The other way you'll find out tomorrow. So I put the blog in the in the chat there. So Chainlink Confidential Compute was announced at SmartCon, which really focuses on privacy. And there are some use cases and things that are listed there. But really what it does is unlock a new class of what we call private smart contracts, right? And you're going to find out what that means in the coming days. And one thing to note is that Chainlink Confidential Compute makes privacy-preserving use cases not only just possible on any blockchain, but it's actually powered by a CRE, which is what this hackathon is all about, right? So, and it uses some pretty cool technology under the hood that I want to just showcase before we continue here. So let's move to the architecture here. So if you have a look here, you see that it talks about 2 things, Chainlink distributed key generation and this thing called a vault DON. So for those who don't know, a DON is a decentralized Oracle network and basically is how Chainlink works, this network of these decentralized Oracle networks. And CRE is no different. There's a bunch of DONs that power CRE. Now, the really cool thing about Chainlink Confidential Compute and the Vault DON is basically the Vault DON can securely store what we call secrets or API credentials or proprietary data in a really, really interesting way using threshold encryption. So what this basically does is, let's say you have an API key or a secret. There are parts of it that are sent or stored on different node operators in the decentralized Oracle network. And then when it comes time to then use that secret as part of an API request or something, it actually goes into an enclave, and the request is done from within there. And CRE itself cannot see that API key or secret put back together. Right, so the privacy is kind of maintained because it's only put together, consumed, and then discarded within the confines of the enclave. So that's kind of how that works at a very high level. But I encourage you to have a read of this blog if you want more information on that. The reason I'm mentioning that is because if you scroll down a little bit further, one of the new use cases that are unlocked by Chainlink Confidential Compute is confidential API access. And that's exactly what we're going to be talking about today. You see access to API data and services. You can kind of do all those kind of things in a privacy-preserving manner where the request or API keys or secrets that go into these requests can be kept private from the CRE network itself, obviously private from on-chain, etc. But not only that, you can also take the response that's given back from the API, and you can also have that remain private too. You can actually have that encrypted using a special AES key, which I will go into in a minute. So this kind of unlocks all kinds of interesting use cases because you essentially have a way to call APIs with secrets kept secret, right? And that's useful for obvious reasons. For example, you might be taking a credit card number from a website, putting it through a CRE workflow, and then you want to push it to an API to do something, to do a payment or something. There's all kinds of rules and compliance around that kind of information. So you don't want your systems, you don't want CRE, you don't want anyone seeing that information and having access to it. So that's kind of like an interesting use case there. But also you can have the response that comes back from the API encrypted in the enclave before CRE even sees it. And there's all kinds of useful use cases around that too. So for example, you might have a credit score or something that's returned and you want to send it on to another system as part of your CRE workflow, but you don't want the CRE, you don't want CRE itself to know what that credit score is for regulatory or compliance reasons. So that's a great way to achieve that level of privacy, is by having the response encrypted on its way back with a special key, and that only certain systems have that special key. And then that encrypted value is then sent as part of the CRE workflow to one of these systems that have this special key, and then they can decrypt the response from that API. So we'll go through an example there. So in terms of use cases and what you can use this thing for, that's kind of the main thing that kind of resonates with me, is anytime you need to get access to some kind of a special API or data where it's kind of sensitive, or the request parameters themselves are sensitive, or the response is sensitive, then this is a great use case to think about incorporating in your project. And we're very interested in seeing what kind of projects that developers come up with that kind of use this technology. So definitely have a think about it and see if it kind of makes sense for you. If you have any questions, feel free to ask them in the chat and I'll answer them. Every now and again, I'll come back to the chat. Now, let me find, where am I here? Okay, so Chainlink Confidential Compute is actually still being built. However, we have a couple of these features that we're going to talk about today and tomorrow. The first one is the one that I just described, and the second one is this other one called private transactions, which we have a workshop tomorrow at the same time. Now, specifically for this workshop, which is confidential HTTP requests, this is actually live in our docs. So let me go to here. So if you go to docs.chain.link, and go to CRE, you'll actually see, if you go to capabilities, the confidential HTTP capability is live. Now, if you don't know what a capability is, that's out of the scope of this workshop. This workshop assumes you have some basic knowledge of CRE, and I encourage you to read up on CRE if you're not sure. But this is a capability within CRE that lets you achieve the functionality that I just described before. So the problem it solves, as I said, regulatory compliance, credential security, and very importantly, response privacy. The way it kind of works is I touched on this a little bit before, where the nodes in the DON reach a quorum on the request parameters. The confidential HTTP DON fetches the encrypted secrets from the Vault DON. It doesn't know what they are. And then the request itself is done within an enclave, and the secrets are decrypted in there. And then if there's a response that needs to be encrypted, that's also done in the enclave before it gets passed back to CRE. And you can kind of, there's a toggle here to specify whether you want to encrypt the response back or not. So in terms of what's kept confidential in this case, what's the privacy preserving, what are the privacy preserving parameters here? So obviously the secrets to the API call are kept private, the request body as well, and then optionally the response coming back if you choose to do so. So there's a few use cases listed here. You can go through them in your own time. And there's also some comparison of when to use confidential HTTP versus regular HTTP. So obviously, if your use case is around privacy and you don't want kind of, you don't want the possibility of either the request parameters or the response being seen by anyone, you'd consider confidential HTTP if it's sensitive data. If you just want to do one API call and not many, you use confidential HTTP, because regular HTTP will do one API call per node in the decentralized Oracle network, whereas confidential HTTP only does one. And then obviously there's regulatory or compliance requirements as well, where you'd use confidential HTTP. So other than the description of the capability, there is a guide here that we will, we have a demo repo that I'm going to share with you, but you can go through this in your own time and see kind of all the steps that are involved. So what I'm going to do next is I'm going to share this repository in the chat so you guys can take a look after. But basically, we've taken this demo and we have implemented it in a repository for you to use as a reference. With a README and kind of all the steps that you need. So, and the thing to note is this workflow, this CRE workflow, we're just going to simulate it. It doesn't touch any blockchains. It's purely to showcase the API calling, the confidential HTTP functionality. And we're just going to be calling an API, and then we're going to be encrypting the response, and then displaying it on the screen somewhere. Now, the API that we are going to call is here at API Ninjas. So I'll put that in the chat as well. This is a free API service, if you will. And you can get a free API key. You can sign up in like 30 seconds. So, don't feel you need to steal my API key when you see it in a minute. But we're going to be calling a jokes API. Let me see if I can find where that was. Yeah, APIs, joke. So we are going to be calling this jokes API to kind of get a joke back, but we're going to do it in a privacy preserving manner. Now I'm going to switch to my code repo here to kind of walk you guys through some stuff. So in terms of what are the things that you need, first of all, you need to set a couple of environment variables. We're not going to need a private key here. As I said, we're not touching blockchains. However, you will need an API key from the API Ninjas site, sorry. And you'll also need an AES key for the re-encryption that happens when the response comes back on chain. So to do this, you could just generate it. I'll show you guys in the steps in a minute. Once you've done that, you're going to have a .env file, and you'll be good to go. So we are going to be adding these environment variables to our secrets YAML file. And in our config, we are setting the URL of the API to the API Ninjas jokes API that I showed you guys before. We have a schedule set for, I think that's 30 seconds, but because we're going to be simulating this workflow, it kind of doesn't really matter. All right, now let's walk through the workflow itself. Maybe I should make this a little bit bigger. So the workflow itself is kind of it's pretty much very similar to a standard kind of example of just doing an API call. Obviously we have confidential HTTP client here. We're building up a config. We have some helper functions that are doing some decoding. But the real meat of this is kind of here, the fetch with encrypted response here. So we're doing our GET request here. We're plugging in our API key here over here. And also here in the Vault.don secrets object here, you can see we're specifying the my API key and then this other one called San Marino AES GCM encryption key. So this one here is just the API Ninjas API key. We're saying we want to store that in the Vault.don. We don't want CRE to know what this thing is. And then the decryption key as well is stored here. So this is actually a very kind of a reserved or special key name specifically for confidential HTTP. And if you store a secret in the Vault.don with this name and you have a setting enabled to, where is it? To automatically encrypt the response, it'll use it to encrypt the response. Now, if we go to the steps in the demo, it'll tell you you need to log in to the CRE CLI with CRE login. Let's see if I've done it or not. I can't remember. Okay, we're logged in, so that's fine. And next up, we need to run bun install. I've already run that. And yeah, that's kind of it. Just going back to the encryption key first, you can generate one if you want with a command, or you can just go to a website to generate one. So we can just take that one there and I can just plug it into here. We have a new one. So going back to our code here, where am I? So this is kind of what this thing here is. So we're injecting that key into here with this special reserved key, and the Vault.don is storing it, and CRE does not know or have access to kind of what these two keys are, basically. So if we scroll further down here, here's what I was looking for before. So this is the parameter that you need to set if you want the API response to be encrypted with this key. So not only does CRE not have access to the key, doesn't know what it is, but the enclave will still use that key and it will encrypt the response. And the idea is that then you take the response that's encrypted in your CRE workflow, and then you pass it on to something else in your workflow. Maybe it's another API, maybe it's an off-chain system. And the idea is that off-chain system also has this encryption key because it's meant to have it, and then it can decrypt the result and see what the response is. In this case, it's a joke string. It does say in the docs here to the purpose of response encryption is to keep the response confidential, even within the decentralized network. Decrypt the response in your own backend service and not inside the workflow. We are going to decrypt it sort of inside the workflow, but we're going to be a bit cheeky just for the purposes of education here. So what we're doing here is we want to do a get to the Ninjas jokes API. We want to inject the API key for the Ninjas API, and we want to inject our AES GCM encryption key as well, so that the response of the joke can get encrypted without CRE seeing what it is. And we're setting this flag to true. Once that's done, there's some kind of console output that's being set here. But then if you scroll down, it's all kind of standard CRE stuff where we're basically sending the request, choosing a consensus mechanism, and doing the request there. So once the request comes back, we then need to decrypt it because we've asked for it to be encrypted. So let's go through the step now to see what happens when we simulate it. Yeah, it's AES GCM encryption. Okay, so if you look at the logs, there's a bunch of stuff here. Let's try and decipher it. So the interesting thing about AES encryption is to decrypt it, you kind of need to do it in 2 steps. So in the encrypted response coming back, the enclave will return a single byte that's typically formatted as like, one long thing, but it's actually got a 12-byte nonce plus a ciphertext and authentication tag after that. So what that means is when we're trying to kind of decipher it, you can kind of see that we're splitting it out by saying the first 12 is the nonce and then the rest is the ciphertext and tag. And to then turn that into something legible and to fully decrypt it, you then combine the nonce with the ciphertext and the key. And then with those 3 things, you can then decrypt it. So you guys will obviously be doing this in code, but what I will do is I will show you this just in an online example here. I'll put this in the chat so you guys can play with it yourself if you want to. But if we take the ciphertext tag and we put it here, oops, we want to decrypt that. Let's start again. It's hex, everything's hex here. The nonce, the first 12 that we stripped out before goes here. And our AES key goes in the secret key here. And then we click go. And there you can see the ciphertext and tag input has now been decrypted, and you can kind of see a joke that shows up there. Okay, I see some questions in the chat. Let me see if I can catch up here. So, great question by Wagdi. The only way to have execution out of DON is by the HTTP capability. So if you want to do a confidential HTTP request like this, you need to use this capability, yes. If you want to do just a normal API call where you don't need the secrets to be kept secret, I guess from the CRE network, from the CRE node operators itself, you can use the normal HTTP capability. But yes, the DON itself cannot do an API call. Sorry, not DON. A blockchain itself cannot do an API call. You kind of need to do it through CRE, through one of the capabilities that I just described. Let's see. Great question here again. How would you decrypt the response not on the workflow by sending it to an API backend? Yes. So the idea is that for the purposes of the demo, I'm kind of just doing it on the front end. But if you take a look at the code here, the workflow is kind of just returning the base 64 of the response. But you could take this ciphertext and the nonce, or just the whole value, because you can strip it out elsewhere, and you could send that to another off-chain system via an API call, right? Via another API call. It can be another confidential HTTP, or it can be just a normal HTTP capability. Or you could write it on chain, and then you could have an off-chain system read the value from the blockchain, or maybe even a front end, and kind of decrypt it that way. But the idea is that whatever the system is that does the decrypting, they also would have this key here, because then they would be able to do that decryption as well. So to answer your question, yes, if you're working within the context of a CRE workflow and you have an encrypted response from a HTTP, confidential HTTP GET, yes, you would send that to another off-chain system or something that's outside of the CRE workflow itself. And that thing would also have the key here, and then that thing would do the decryption, and then you could do whatever logic you need to do after that. Great question. So I want to show what happens now if I change this parameter. Where was it? Encrypt output. If I change it to false, I'll leave this in there even though it's not really going to be used. And I'll show you all, if we do another simulation and then we take a look at the returned value here from the workflow, you can kind of see that looks a little bit different. But if I just, it's in base 64. If I just try turn it into hex without doing any decryption, without the AES key, sorry, you can kind of see, hopefully, there you go, that we were able to see what it is without having to decrypt it, because it wasn't encrypted coming back. So to encrypt it coming back in, you need to make sure that you have this specifically set to true, and you need to make sure that in your secrets you have this specified. Hopefully that makes sense for everyone. So one thing that's kind of obvious after seeing this demo here is that CRE was used to interact with an API in a really secure and privacy-preserving manner. Where the API key itself, it was kept private. The AES encryption or decryption key as well was used. It was injected into the request, but it was also kept private. CRE had no visibility on it. It does not know what it is. It cannot decrypt the joke response coming back when it's encrypted. And yeah, it's kind of clear that with this confidential HTTP capability, CRE becomes a very powerful orchestration layer between APIs, off-chain systems, and blockchains, where you can kind of connect and interact with these APIs in a very secure and privacy-preserving manner. And this is really cool because it enables you as a developer to unlock some great privacy-focused use cases, whether it's private prediction markets, private DeFi markets. You can kind of really unlock some cool things once you actually think about this. And before I share the call to actions, I really want to reiterate to everyone to think about whether you're building something that's in DeFi or prediction markets or stable coins or compliance. Think about how can you add a privacy aspect to your submission, and then really think about if it makes sense to incorporate something like a confidential HTTP request in your CRE workflow. And if you can, I urge you to play around with this, play around with the demo, and try and incorporate it into your submission. We're very interested to see privacy, how people think about privacy as part of their CRE workflows. Another thing I want to reiterate is that you don't have to have your workflow deployed onto CRE for a valid submission. What I showcased now, where I simulated the workflow, that is enough for a valid submission. We want to see the workflows itself. We're not as interested in seeing full-blown end-to-end working applications. And while we do encourage you and we'd love to see them, it's the use case and the workflows themselves that we're really interested in. So if you could just showcase a simulated workflow in your video, that's plenty for us. That's awesome. Okay, let's get to the call to actions. I haven't seen any new questions yet, but if you have any, please feel free to share. So I'm going to share 3 links in the docs, in the comments again. So first of all, the documentation is live on docs.chain.link. You go to capabilities or workflow guides, and you'll see confidential API interactions and confidential HTTP, where it explains the capability. I think I shared the GitHub repository that has the repo that I just showcased to you just now, and you can follow all the steps and kind of do it yourself. And it also has links to the API that we've used, as well as a front-end tool for decrypting if you want to try and play around with it yourself before you try to do it in code. If you run into any blockers or issues, please reach out to us on Discord. We have dedicated support channels there. I check it every day. I keep a track of the privacy stuff especially, but we have a team to kind of keep track of that, and we can help you out. We also have some office hours scheduled. I think they're coming up if they haven't already started. So if you take a look at the Hackathon website, you'll see the schedule for that, where you can join the office hours. In fact, let's take a look together. You can join the office hours and you can... oh, the last two links are not working. Okay, sorry about that. Let me try and fix that. There's one, and there's two. Let me know if that's not okay. Thanks, guys. Yeah, so you can see the office hours are listed here, starting on the 20th, so this week, and you can join them. You can, we'll have a Devo engineer there. You could showcase your code. You can share your idea. It's basically just a session for you to kind of ask for information or get support or validation of your use case. So feel free to show up, and we're happy to chat with you, vibe with you, and help you to be as successful as possible in this hackathon. So yeah, please, I encourage you guys to do that as well. Okay, I think that's it for now. If there's any other questions, like I said, Discord is great. Office hours are great as well. Please reach out, and yeah, really encourage everyone to think about privacy as part of your CRE hackathon submission. And if this got you a little bit interested, definitely catch me tomorrow again at the same time, where I'll be showcasing the other part of what we have available for privacy in this hackathon, which is private transactions. So we'll be showcasing how you'll be able to privately do token transfers or compliant token transfers using Chainlink Confidential Compute, an early version or early access version of it. So thank you, everyone. Hope you have a great rest of your hackathon experience. It's been great interacting with you all here and sharing some of this cool new technology with you all. And I look forward to seeing all of the amazing projects submitted. Thank you.